Thanks, Chad, for the intro. And hello, everyone. Thanks for joining today to this presentation. So today we will introduce Click2Cast, the casting simulation software. We will introduce version 3.0.3, that is our current release version, and to talk about a little bit about the history of Click2Cast. Click2Cast was launched to the market in 2012. At this time, version 1.0 was only for feeling analysis. 1 year later, we released version 2.0, adding the solidification capability to the software. So in this version, you were able to run both feeling analysis and solidification of the component. And then 1 year later, we released version 3.0 that allows you to run many of the processes that you can find in the casting industry. We will see later what are these processes, but nowadays we are preparing version 3.1 that it will be released in the near future. So let's start talking about what is Click2Cast. Click2Cast is a casting process simulation software, but it's developed under a particular concept that is based on usability. Usability means that we allow the user to enhance and optimize manufactured components, avoiding typical casting defects such as entrapment, porosity, cold shots, cold welding, etc., but thanks to a simple and quick mold filling and thermal simulation. Click2Cast offers a really innovative user experience and allows you to complete the simulation in only 5 steps and through a very simple and friendly user interface. To show that, let me present this video. So as you can see, in less than 2 minutes, we are able to run a complete simulation of filling and thermal analysis of a casted part in order to analyze if we will have some defects, if we can improve the design of the process or the design of the component. So what can we do in Click2Cast? Click2Cast, we can perform simulation for most of the most common processes in the casting industry. This means that we can perform analysis of high pressure die casting, low pressure die casting, gravity sand and tilt pouring casting, and of course permanent mold casting for gravity simulation. Okay. What are the advantages of Click2Cast compared to other softwares in the market? First of all, and the most important, is that we can perform early simulation. What does this mean? This means that we don't need to define the whole process to start making simulation and to start understanding what is happening in our process. We can perform simulation just with the raw part, I mean with the designed component, without any running system, without any overflow, or without any air vents. The second key point, or the second advantage of Click2Cast is the usability. As you just seen this video, Click2Cast is really easy to use, and this is our main focus, when we are developing Click2Cast. Our main focus is to develop a tool that anyone can use it, and a tool that no one needs a particular training on the use of the software or in the particular technology for finite elements or for numerical methods. The fact that this is really easy to use and it is really intuitive allows us to make quick iterations between different possibilities to fill the part or to design the process for the casting. So we can make quick iterations and modifications of the part to improve our process and our design. Okay? And all this with a limited investment, not only because of the cost of the software, but also because of the time investment that we need to run a simulation. Normally, to run a complex simulation, it takes hours or even days, depending on the complexity of the geometry. So with Click2Cast, it is only takes minutes, or in case of complex geometry, some hours, but never it takes much more than 1 hour. And basically, it allows us to keep the know-how in-house, because we don't need to give to third-party companies to run simulations, because as anyone can use it inside our company, we can keep the know-how at home. What are we offering to the user, or what possibility offer Click2Cast to the user? Normally, current casting simulation software are helping us to answer the question, how is my shot design, or how good is my shot design? But Click2Cast goes some step before answering this question, and it will help us to determine the best position to place the engate, or where to place feed or risers, and which size we must allocate for these risers and feeders. It allows us to answer the question if we have to use continuous engate or fan engate, where to put vents or overflows, and how to balance the multi-cavity flow. So all these questions are really, really easy to answer by using Click2Cast, starting from the raw part. Click2Cast is divided in 5 steps. So this means that it's a kind of wizard to run the calculation, and let me show you basically what are these 5 steps. First step is open the geometry. It's a simple step in which we will import the geometry in STL format. We can visualize the geometry, and we can open an already calculated project, of course, to change any parameter or to modify something to run a new calculation. The second step will be defining the ingate and mesh. Defining the ingate, Paul will explain you later in the live demo, but this is really, really easy because we have 2 different ways, automatic or advanced way, but both of them are really, really easy and convenient for the user. The third step will be the setup of the process. In this case, we will have to set up basic parameters for the process, like material parameters. We have a database for the most common material for part and for mold. And finally, we will have to define the process parameters like gravity direction, velocity of the piston, or flow rate of material, etc. This is really, really parameters, process parameters. It's not technology parameters. And finally, we have to run the calculation, of course. We allow the user to run both filling or solidification analysis together, or to run a filling analysis and a solidification separately. Finally, we have to analyze the results and to check if we will have some defects. Click2Cast has many possibilities to analyze these results. We can perform a front flow animation in order to understand how is evolving the liquid material inside the mold. We can check the temperature evolution of the material, the velocities, cold shots, air entrapment, mold erosion, and so on. And finally, for the solidification analysis, we will be able to understand how is the solidification evolving, if we will have porosity, how many amount of how much porosity we will find in the part, what are the critical areas. We will be able to place label, to make graph, and to visualize the results in the most convenient way. But for this, I think the most optimal way to understand is to make a live demo. As Click2Cast is really, really easy to use, it allows us to make a demo in a few minutes. So please, I will give the controls to Pau Tourné, who will be in charge to make the live demo of Click2Cast. Thank you very much.
Hello to everyone. My name is Pau. I'm part of Click2Cast support team, and I'm going to show you a live demonstration of the software. Okay. So as Martin said, we have 5 steps, and the first one is the geometry. This step is just to open the geometry. As Martin said, Click2Cast works with STL files. So I'm going to open a file. So this is typical STL file. As you know, every CAD can export in this format. This is a very typical format. So once we have imported the file, we have to set up the length units, okay? And that's all. We are ready to go to the next step. Next step is meshing step. In this step, we will create the mesh to run the simulation, and we have to set up only 2 things. One is the ingate. The ingate is where the material comes into the part, and the other thing that we have to select is the element size that we want to create for this mesh. Okay, so in this case, for example, I will use, well, in fact, we have two ways to select this ingate. We have an automatic way in case that we have a previously designed filling system. For example, this one, we have a filling system, and just clicking automatic, add ingate, and selecting the surface, we will set up this ingate. In case we don't have the filling system, we can create a virtual ingate. Click2Cast allows us to create a virtual ingate in order to make a quick simulation without having to go back to the CAD and drawing a new filling system and so on. We just clicking on advance and select the kind of the ingate. If we want to draw a square or a circle, for example, in this case, I will use a square. We have to select the size of this ingate, the orientation of the part that we want to place the ingate, and then click on add ingate. Click over the part, and the ingate will be positioned. Once we have the ingate, we have to select the size of this mesh. Okay, in this case, I will try with 2 millimeters for this mesh, and click on create mesh, and the mesh will be generated automatically. We don't have to do anything. We don't have to handle with the geometry. We don't have to repair nothing. Just select our ingate and the element size. Okay, so in this case, we have the mesh ready. Now, as you can see, we have generated the mesh, we have the ingate, and we are ready to go to the next step to set up the parameters. And in case that we want to change the size of this mesh, for example, if I use 3 millimeters, we will get a mesh with a low quality. So depending that we want a fast simulation, we can use a mesh with a low quality using a big element size. Or if we want to increase the accuracy of the simulation, we can reduce the element size of the mesh. It's depending that we want. We want a fast simulation, we can do it with a big size, and if we want a more accuracy simulation, we can use a small element size. Okay, so once we have the mesh ready, we go to the next step, and this is for set up the parameters. For setting up the parameters, we have to select both things. One is the material, the casting material and mold material, and then the process parameters. To select the casting material, we have to select, we have several kinds of alloys. This is the most typical alloys, most common alloys in the casting. So we can select, for example, steel, carbon steel, alumina, brass, and inside of every material we can select. We have several types of alloys of this material. Okay. Then once we have the material, we have to select the casting temperature, and the same for the mold. The material of the mold and the temperature of this mold. Once we have selected all these materials, we have to select the process parameters. The first one is the gravity direction. Gravity direction means the position that we have into the mold of the component. In this case, this is the position in the mold, for example. So I will select this gravity direction is negative y. Okay. So once we have the gravity direction, we have to select the setup for this process. We can do it with the basic option or with the advanced one. With the basic, we can select the velocity at the gate or the filling time, the total time that takes this component to fill. And for the advanced options, we have several options for the high pressure die casting process, in particular for the low pressure die casting process and for the tubing, but I will show you later. For this simulation, I will select, for example, a filling time of 2 seconds. Okay, and that's all. Once we have the setting up, the parameters, go to the next step. To launch the calculation, we can launch the filling animation, we can run a solidification, or we can simulate the filling and also the solidification, and click on run simulation. Okay, and the calculation will start. We don't have to wait until the end of the calculation to check the results. We can, once the calculation reaches the 1%, we are able to go to the next step and check the results. Okay, so let me open, well, in fact, I have previously calculated this component, so I will show you this result. Okay, so if you remember, we have placed the ingate at this position, and we will see the animation of the evolution of this material coming into the part using this ingate. Okay, as you see, we have 2 different fronts in this animation. So, okay, we have 2 different fronts. So the material is colliding. So maybe this is not a very good place to put the ingate, because we will find a lot of turbulences. For example, if we check the velocity, we can make a cut using this tool. This is the scissors. Just clicking over 2 points, we will see a cut inside of the part. This is very, very simple. And checking the results of the velocities, we can see how there are a lot of turbulences in this area. If we play on the visualization, we are seeing all this turbulence in this area. So this is, maybe we can think that this is not a good place to put the ingate. So the good thing with Click2Cast is quite easy to change this ingate. Just come back to the meshing step, click on delete ingate. I will delete this ingate, and I'm going to create a new ingate. For example, I'm thinking to place the ingate in this area in order to get a continuous fluid and avoid these 2 fronts that we are having. For example, I'm going to use this orientation. I'm going to use a different size for this ingate. For example, for the height, I will use 3, and for the width, I will use 25. Okay, and click on Add Ingate. Click over the surface, and that's all. We have a new ingate. Click on Create Mesh, and the mesh will be generated automatically. Okay, so now we have a new ingate, and let me show you this new position using this new front evolution using this new position. Okay, now the ingate is in this side, and I will show you the evolution of this using this new ingate. Okay, now the fluid is more stable. We are avoiding these 2 ways of filling that are having caused some turbulences, and now we have a very stable filling. So if we decide that this is a good place to ingate, we can check, for example, temperature evolution during the filling. we can take some pictures just clicking on this button, and we go to this folder and we will see these pictures. As you see, it's very simple. Just click on this icon, and the same for the videos. Just clicking on this button, we will create a video, and it will go to the same folder. As you see, it's very, very simple to use. We can check the velocity, also the velocity. This is velocity vectors, and most of the buttons have a second option. If we click twice over the same button, we will see the same velocities, but in an isosurface mode. Okay. We have to check also the call shots. We can check also the entrapments. Okay. This is very useful to, for example, in this case, this is a gravity die casting process. So we can check in this entrapment. We can place here a riser in order to avoid all this porosity. Okay. We can check the filling time, solid fraction. This means that areas that are solidified during the filling, okay, and also the pressures. And as you know, for the gravity castings are also very interesting. Study the solidification. So I will show you the solidification results. This is the temperature evolution during the solidification. We have, for example, we have the opportunity. We can make some cut at this area, and then with this option, with the grab option, just clicking over the surface, we can generate a graphical by an easy way. We can export all this data. Okay, so as you see, it's very, very, very simple. Just clicking over one or two buttons, we can create all the animations. For example, this is very interesting also to study. This is the solidification, the solid fraction evolution. Okay, so these options show us how this component is solidifying. All the red area that you are seeing is the liquid material. So we will see how this component is solidificating. In this case, for example, we will see all this allocated material that we can create some porosity, and we can see how most of the porosity will be located in this point, because this is the last point to solidify. Okay, so this is very interesting for option to check the solidification results. Also, we have the porosity option, but this option is the same than before, but it shows the size of this porosity. This is the shrinkage porosity, the porosity due to the contraction of the material during the solidification. So with the option, we can see where is located this porosity and which side is having, in order to avoid this porosity. How can we avoid this porosity? So, as you know, one of the ways in gravity castings is placing a riser. So with this option, is very useful to know where is this porosity, and to know, if we want to know how to avoid this porosity, we can use this riser designer option. That this option will allow us to avoid this porosity by giving us a size which is the optimal size to avoid this porosity. How can it work? So we have to introduce the casting modulus. What is the casting modulus? Casting modulus is this option. This is just the division between the volume and the surface. So it gives us what is the maximum porosity. In this case, maximum porosity is located at this area, and it's 0.2 centimeters. So introducing this solidification modulus, this feature will give us the optimal size for this riser in order to avoid all this porosity. Okay, so this is very useful because once we have this size, we can go back to OCAD and design a riser and simulate all together the filling system, the part, and the riser. So, for example, let me show you. This is the same component, but using this riser and the filling system. So we can analyze how is evolving this material inside of using this filling system, and then we can also analyze the solidification, but using the riser. Okay, so in this case, we can see the solid fracture evolution, and we can analyze the same than before, but using this riser. Okay, this is very useful. So, as I said, I show you the basic options for the process parameters. So let me show you now some fast, a quick view of the high pressure decasting, the low pressure, and the tilt point. So regarding high pressure decasting, let me show you this component. Okay, so this is a housing. This is a typical high pressure decasting process. So once we have the mesh, we have to set up the advanced option, clicking on this button, and then we have high pressure, low pressure, and tilt point. Select high pressure decasting, and we have to select for the high pressure decasting the first and the second phase velocity. As you know, in the high pressure decasting process, we have two different velocities, because the first velocity is a slow velocity in order that the fluid fills the piston cavity, and once this piston cavity has reached, we have to set up the second phase, that is a very fast second piston velocity. So we can set up these two velocities. The first one, for example, is a low velocity. We can use 0.3, and for the second one we can use, I don't know, 2 meters by second, 3 meters by second. It depends on your process. And then click on this point and select a point where the material reach this point will change to this second phase velocity. Okay, and that's all. We have only to select the first velocity, second velocity, and the point to change between these two velocities. And go to next step, launch the calculation, and check the results. Okay, in this case I will show you the results of the high pressure decasting. When the results are loading. Okay. Now we have the results. We can analyze also the evolution of the material coming into this part. Okay. Maybe for high pressure decasting is more interesting to study the filling analysis more than the solidification, because as you know, the filling of the high pressure decasting is very fast. So we can, for example, it can be interesting to study all the air entrapments, for example, during the filling. In this case, we can study how these overflows, these vents are working, if they are catching all this air well or not. It could be interesting also study the temperatures, also the velocities. For example, in this case, we can see the evolution of the filling. We can see, I'm going to the end of the filling. Okay, and we can see how these overflows are working properly. So they are all the last area to fill is the overflow. So all the porosity will be located in the overflows. So this is a good thing. In this case, we can analyze also how it's closing this filling. So in order to know it is working properly. So in case that one overflow is not working properly, this is very useful because Click2Cast can show us using this tool, air entrapment tool. So here we can see where are all the air trapped. So we can see how most of the air trapping are located in the overflow. So for example, in this case, there are some air trapping here, but there is no overflow. So we can move this overflow in order to avoid this porosity. So I think this is a very interesting option for high pressure die casting. Other option that we can check is the mold erosion. This also very interesting because these options show us the degradation of the mold. In this case, is showing up where is placed most of the degradation. This is near the gate. That's because the gate is quite thin and the velocity is very high. So as you see, we have a scale here. So velocities are around 80 meters by second. So this is very, very high velocity. So the degradation of this mold will be very high. So using these results, we can go back and check a different velocity for the gate in order to avoid all this mold erosion. Okay, so we can also analyze pressures, also solid fraction, filling time, and as same as the gravity, we can also analyze the solidification results. Okay, this is the porosity. As you know, most of the porosity is located at the piston. We can analyze also the temperatures. We can see the evolution of the temperatures. Okay, and the same one for the solid fraction, solidification time, and the porosity. Okay, regarding, I didn't show you the gravity and casting process. I already showed you also the high pressure of the casting, and I'm going to show you now, for example, a low pressure of the casting process. Let me show you, for example, this case. This is a low pressure. I will use this one. Okay, so this is a wheel rim. This is a typical low pressure die casting component that I will show you how it works. So the first thing that we are seeing here is the filling evolution. So as you see, this is the evolution of the filling. Okay. And if we go to the end of the filling, we can see how the simulation has not finished. Okay, why is not finished the simulation? We check the temperatures, for example. We can make a cut of this section using the scissors, clicking over 2 points on the screen, and we can check the temperatures over this point, clicking in label, and as you are seeing, the temperature is around 5,700. So probably the material will solidify and the filling. That's why the filling is not completely. So if we check the solidification, the solid fraction, we will see how this component is totally solidified and is not filling. So what we can do in order to avoid this, we can go back to the parameters state, set up a different parameters. For example, for low pressure die casting, we are using this pressure curve. Okay, so this is the same that we are using in our computer. In our machine. So if we are using this pressure in our machine and we simulate this process, we realize that there is not filling. So we can change all this pressure, increase this pressure in order to get a good filling of this component. Okay. So once we have modified this pressure, we can go to the next step and launch again a new calculation and check the results. For example, let me open this one. This is with the parameters modified, and then we are going to analyze these results using these new parameters for the low pressure decasting process. Okay, so as you see now, you can see the evolution of the filling. And now we can see how the part is totally filled. Okay, so it's very simple. Just go back to the parameter stage, change these parameters, and launch again the calculation. We can check again all the results, all the temperatures, velocities, and so on. Okay, this is regarding low pressure decasting, and the last one is the gravity chill pooling. Okay, so let me open a typical chill pooling geometry. For example, I will use this one. Okay, so regarding chill pooling, we have to set up also the gravity direction. This is the position that this component has into the mold. Okay, in this case, this is the gravity direction. This is positive y. And then we have to select the rotation time. This is the time that takes to rotate in the machine, and the initial angle. Okay, so once we have set all these parameters, we go to the next step, launch the calculation, and check the results. Okay, so if you click on play, you will see the evolution of this material rotating into the chill pooling. Okay. We can study also the filling evolution. We can study velocities, gunshots, enchantments, filling time, the same than before. As you see, it's very, very simple. Just selecting with one click, we can check all these results. And if we want to change to the solidification results, click over this button, and we go to the solidification results. Okay. Okay, so as you've seen, this Click2Cast, this is very simple to use. As you have seen, just with a very few clicks, you are able to generate a simulation, to run a simulation, and that's all. I don't know if you have any question that I can help you. You want to see any process in particular or so on?
Great, thank you, Pau. This is Chad back again. Really quickly, before we move on to our questions and answers, I did want to open up a poll really quickly for everyone who's joined us today. And thank you for watching the great demo. So you'll notice a poll up on your screen right now. We'd like to know if you're interested in a free trial of Click2Cast. Please feel free to answer that poll. I'll give about 45 seconds, and then we'll move on to question and answer. Again, while you're answering that poll, if anyone does have any additional questions, we have a few already that you've asked in the questions panel. But if you have any additional questions, please feel free to type those there now. Take about 10 more seconds if you haven't answered the poll question yet. Okay, thank you everyone. Martin, I've also unmuted you, so feel free to chime in on any of these questions if you'd like to answer. But the first question is, and this was about the demo, did you specify a cooling time or a solidification time? I only saw filling time specified. Pao, are you there?
Yeah.
Did you hear the question?
Yeah.
We will send this presentation and all this material that they want. This is not problem for us. We will send it.
Regarding the comparison between some with the real life, we can prepare some presentation, or we can send some documentation regarding that.
Or case studies.
Or some case studies. We are preparing some case studies to share with the customers. Okay.
Great.
Regarding the format for importing geometry, for the moment we are using STL files. Okay, we are using STL files because we can, in this way, we can perform automatic reparation of the geometry. Our meshing tool is able to clean the STL files automatically. We can close holes. We can remove any element that is not useful for the geometry. We can do many operations to prepare and repair the geometry automatically. So in this way, we are using only STL files. Okay. Regarding the question of build calver, we are not specifying any cooling time. The cooling time is determined by the solidification analysis. I mean, the mold that we are using is the one that is defining the cooling time. So this is a calculation result. You can see the solidification time, for example, in the post. This is as a result. Okay. If you go to post process, load the solidification analysis, you can see solidification times everywhere in the part. Okay. So in this way, you can make a section to understand what is the solidification time all over the part, and also at the central area of the part or anywhere. Okay. Regarding Bill Calvert also asked about how these results are compared with the physical part. Again, we can provide, in the near future, we will be able to provide some user cases and success story regarding this comparison. We can contact you and send you some material. Okay. Then we have a user, Wolfgang Geist, that is asking about is based on Inspire or other tools. It's a really the workflow is really attached to Inspire. So this means that you can work on Inspire to design your geometry or to run a topology optimization of your geometry, and just after that you can export the resulting STL file to Click2Cast, and you can run a complete simulation by using Click2Cast. But for the moment, it is a separate technology, and we are using different base tools. Okay, this is only for the moment. For casting, regarding Peter Rolls, he's asking about casting material. He said, for casting material choices, I noticed plastic wasn't an option. Are there any add-ons for plastic? No. Click2Cast is only for metal casting. This means that we can consider any metal alloy, such as steel alloy, cast iron, copper, aluminium, SAMAC, and other metal alloys, but not for plastic. Okay, sorry for that. What if the geometry is not perfect, say Sylvain? If there are any gap in the geometry, you don't have to worry about that, Sylvain. Click2Cast can repair almost all the problems that we have in the geometry. Of course, before exporting the geometry, you have to take care about exporting one single solid. Okay, this is the only condition we are asking to the user, that from the CAD, from Inspire or any other CAD you are using, or any other tool you are using to prepare to define the geometry, you have to create a single solid, and after that you can export the solid in STL format to Click2Cast. Then if the STL file has any gap or any T-junction or any other problem, we can repair automatically. What kind of fluid numerics are this simulation based on? Okay, regarding Felix Radic is asking about the fluid simulation. I think your question is about the CFD, the fluid dynamic simulation. Currently, we are using an Navier-Stokes calculation coupled with the thermal analysis and computing the free surface of the material using a biphasic flow. So I repeat, Navier-Stokes uncompressible fluid coupled with thermal analysis and considering the biphasic fluid to compute the free surface of the material. Okay. Aris Salonen asked if will you develop a version for injection molding in the future? This is something that I cannot answer today. We are quite new in Altair. As you know, Click2Cast was acquired by Altair a few months ago, and in the past it was not in our development plan in Click2Cast plans. But as you know, Altair has many other teams that we can join, make strong our development team. So in the future, we don't know if we will include or not any plastic injection molding. For the moment, I have to say no, but you never know what can happen in the future. Kadirvel Mutsusami, sorry about the pronunciation. Kadirvel, how will you add the isothermic sleeve properties and chill properties? Well, in Click2Cast 3.0, this is not included, but let me make an advance of what will be the future version of Click2Cast. Okay, in the Click2Cast 3.1, this is a beta version. This is not a release version. Okay, this version will be released some month later. Okay, but we will have the possibility to add sleeves and other components to the part by adding some additional components. In this case, you will see that we will be able to add some core, a different mold material, chiller, and sleeves. So by clicking on the type of additional component we want to select, we will be able to add this material to our part, and we will be able to set up a complete calculation considering additional materials like core, sleeve, chiller, or two types of molds. Okay. I think this is your question, but you will have to wait some months in order we will release this new version. Is this product available for Indian customers, say Arun Venugopal? Yes, this will be available worldwide through the SolidThinking network, distribution network, and you can find some information in click2cast.com. But of course, it will be available for Indian customers. Giri Panek asks if it is possible to export stress displacement for next FEM analysis. Giri, for the moment we have no stress analysis in Click2Cast. What we are able is to predict the porosity. This means the void areas inside the part you can find after solidification. In the mid-term future, we will be able to predict solidification and deformation of the stresses and deformation of the part after casting, but for the moment this is not possible to do in Click2Cast. Mahender said this is only filling time is entered. We did not enter solidification time. Okay, this is an answer for another user, I think. Siyong, who is asking about, does calculation time depends on the total number of cells, such as some areas is very thin? No, well, yes, in fact the calculation time depends on the number of elements or the number of cells. This means that if you increase the number of cells, calculation time will increase, but also accuracy will increase. So if we are using a low number of tetraedrals or low number of elements, calculation time will decrease, but accuracy will also decrease. So this is a question of a balance between calculation time and accuracy. Ari Salonen asks if does it run it on Mac? Not yet. maybe in the near future, Ari. We are thinking to release Click2Cast for different operation systems. Mohammed asked if he can we get the material strength after solidification? Not for the moment. As I mentioned, we are working on that, and it will be possible release in a midterm future. Lucas is asking if it is possible to output any mechanical quantity as stress and so on. Same answer than Mohammed. Maybe it will be possible in the midterm future. Camille, is it possible to see material parameter? Camille is asking about the possibility to see the material parameters. Not in Click2Cast 3.0. What we have in database is, let me open an already calculated file, like this one. What we have in database is all the properties for each material you are using. Okay, these properties mean thermal properties and physical properties for the feeding analysis. All the properties are temperature dependent, so this means that the conductivity of the material is included in this material database, for example, and this conductivity is has a dependency on the temperature. This means that the conductivity of the material at 700 degrees is not the same that at 300 degrees or environment temperature, and we are taking that into account. But all properties you need are included in the database. So in the near future, in the next release, Click2Cast 3.1, we are preparing a special window to offer the user the possibility to check these properties and to modify any properties he may need. Okay, so in future version you will be able to check these properties. Regarding Lucas is asking about how reliable are the results. As I mentioned, first it depends on the mesh size, but we are getting good results, and we have more than 100 customers all over the world, and they are really happy with the accuracy of the software. It takes very few minutes to run a calculation, but the accuracy is really good because we are using very powerful solvers for fluid dynamic and thermal analysis. So as I mentioned, in a very few days we will be able to share with you some success story, but also you have the possibility to check by your own by downloading a trial version of Click2Cast. Within few minutes you will be able to run a calculation, and you will be able to check the real accuracy of the software. This is quite easy to use, so you can start using Click2Cast just today. Idris is asking about the possibility to simulate casting for medium size and large size stamping die, which is using casting material. Yes, of course. You can simulate any component made by metal casting. It doesn't matter if it is high pressure die casting, low pressure die casting, or gravity casting. It will not be a problem for you to simulate stamping dies using casting process. Regarding theoretical references that is asking Lucas Tilner, we can share with you some material in our website. It's not we didn't publish anything, but if you need, you can contact us by email, and we will provide some theoretical references you can read. Let me follow with Prakash. Can we use data in other format than in STL? Not for the moment. Maybe in the near future we will integrate some tools in Inspire, and you will be able to use Inspire format, but for the moment we are only using STL format. Mohammed is asking if he can get the material strength after solidification. I say no for the moment. I'm sorry for that. Ilan is asking again for plastic injection analysis. Not for the moment, as I mentioned, and maybe in long-term future, but not for the moment. And if we can consider multiple cores, of course, we can consider multiple cores, multiple parts, multi-cavity components. You can consider every single component in the casting simulation process. And regarding the price of the license, Chad, I think this is I don't know if we can ask this kind of questions right here, but you can answer by email. We can send to you an economical offer by email. I'm sure of that. Yeah, regarding machine multicore, yes, of course. If you have a multi-core computer, you can run taking profits of parallel computing. Click2Cast is developed, our solvers are developed based on parallel computing, so if you have a multi-core machine, you will profit all of your cores. Okay, Chad, I don't know if there is another question. I hope I was enough clear. If not, please, you can contact us by email, and we will come back with all the information you may need.
Absolutely. And thanks so much for answering all those questions. And thank you, everyone, for the great questions. If there were any we did not get to today, we will follow up through email. And once again, you can visit us on our website, and we hope to talk to everyone soon. Thank you to both of our presenters and to everyone who attended our webinar today. Have a great day, everybody.
Thank you very much.
Thank you, Chad.
Thank you.